Welcome back. So, in this video, we'll go over naman yung ating second method to simplify the recurrent relation to get the time complexity using the recursion tree method. So, for the recursion tree method, mas visual siya na approach wherein we actually draw what we call a tree in computer science na ayan, so basically, sinusulat natin yung recurrent relation na tree. So, you'll get why later on. But before that, medyo hindi kasi tree yung first example. So we have another example of a recursive function here, which is called binary, which prints all the n-digit binary numbers. So paano siya naging recursive function? So basically, ang ginagawa niya is that to get all the n-digit binary numbers, we get first all the n-1 digit binary numbers. So for example, we want to get yung ating 3-digit na binary numbers. So we get all the 3-digit binary numbers by first getting yung ating mga 2-digit na binary numbers. And then appending either 0 or 1. And by doing so, we actually, ganyan yung ating makuha function. So, lahat ng mga 2-digit binary number ay just yung mga 1-digit na binary number na merong 1 or 0. So, yung isa. So, yung 1-digit natin is, ang 1-digit natin ay either 0 or 1. So, yung ating mga 2 digits ay yung mga 1-digit number na lalagyan natin ng either 0 or 1. So, 0, 0. Or 0, 1. And then, ito din, 1, 0. Tsaka 1, 1. So, yung mga 3-digit naman is magdadagdag ako ng 0 or 1 dito. 0, 0, 0. 0, 0, 1. Or yung dito sa dulo, 1, 1, 0, 1, 1, 1. So, ganun yung nakuha natin dyan. So, we can actually run this code. Walang function. So, let's call binary tree. So, we should be able to get all the 3-digit na binary numbers. And then, if gawin ko itong 10, should get all 10-digit binary numbers. Starting from, let's scroll. Medyo mahaba. Ayun, so from hanggang all ones from, so medyo madami. Kasi madami 10-digit na binary numbers. 1,025. So, close ko na lang. Anyway, so paano natin isusulat yung recurrent relation nitong function na to? So sa recurrent relation, we have 2 times t of n-1. So bakit 2 times? So we have 2 recursive calls. So 1 over here and 1 over here. So these 2, sila yung kaya siya times 2. Tapos n-1 yung kinocall natin dito, kaya n-1 sa loob. And then, bakit may f of n tayo dito? So that just encapsulates or ang ating placeholder para dun sa time ng paggawa nitong addition na to and yung pag-compare and everything else. So actually, yung addition na to is probably linear time. Pero ayun, based actually depending doon sa inyong Python version, baka magkakaiba. So for now, let's just say na f of n siya. So, wait. So next, itong g of x, siya naman yung ating time para dun sa ating base case wherein we print the result ng pagbubuo ng ating mga binary numbers. So g of x siya for now. So kasi, well, depende kasi kung anong reference mo gamit natin. Yung ating print function, it can be a constant operation or it can be a variable time na expression depending doon sa contents na i-print natin. So, moving on, paano natin ito gagawing tree? So, we have a GIF or animation over here. So, graphically, we are expanding yung ating recurrence relation. So, to maybe slow down a bit yung ating animation, I have the actual slides over here. So, starting from the recurrence relation na nung original na function call 2 times t of n minus 1 plus f of n, we get yung ating dito recursive call 2 times t of n minus 1. So si t of n minus 1, when we expand it, it's 2 times t of n minus 2 plus f of n minus 1. So bakit f of n minus 1? Kasi dito t of n, f of n. So pag naging n minus 1, yung ating ina-expand, we get n minus 1 din sa f of n. So dalawang branch to kasi dalawang recursive call yung ating function. So since yung dalawang recursive call nilagay natin dito sa baba, we can remove it from this level or from this line. So matitira na lang doon is f of n. Then for focus muna tayo dito sa isang side. So similarly, yung 2 times t of n minus 2 na to, pwede nating i-expand to 2 times n minus t of n minus 3 plus f of n minus 2 plus. Yun, dalawa kasi sila, so dalawa din silang nandyan. And since ito is bababa dito sa level na to, ang matitira sa cell na to is si f of n minus 1. Then, I can actually expand this again and again. So matatanggal yung recursive call, may iwan yung f of n minus 2, and you can predict, so para meron may pattern, di ba? So f of n dito, f of n minus 1 dito, f of n minus 2 dito, n minus 3 dito, and eventually pupunta siya sa f of 1. And then pagdating sa f of 1, going back to the function, magiging f of 0, and magiging dalawang call siya to g of x. Kasi si f of 1, magtatawag siya ng dalawang f of 0, and si f of 0 ay g of x. So dalawang g of x pagdating kay f of 1. So similarly, itong isang branch din na to, so kaya siya tree kasi sisimula ka dito sa tinatawag na root, tapos nagbabranch siya. So medyo baliktad lang kasi yung root niya nasa taas, yung branch niya nasa baba. Pero it's just a matter of, pwede ka naman baliktad rin to, so magiging actual tree siya. Pero anyway, mas appropriate kasi to going down kasi paliit ng paliit. And yun, similarly, yung f of n, itong 2 times t of n minus 4, eventually magiging ganito rin yung itsura niya. So basically, madaming f of n minus 4, madaming f of n minus 5, hanggang madaming f of 1, and maraming g of x. And then similarly, yun din yung mangyayari sa other branches dito. So magiging ganyan. Then, pag pinuo natin siya, eventually, magmumukha siya. Ganyan. Now, pagdating sa mga tree, we often talk about the tree based on their level. So parang, as you can see, lahat nung magkaka-line or magkaka-level, pare-pareho lang yung laman. So it would help if we have some sort of distinction or term for that. So what we call yung mga magkakalinya is what we call level. So yung level is yung ating distance from our starting point or the root. So dito sa f of n minus 3 na to, it takes us 1, 2, 3 steps bago makabalik sa root. So ang masasabi natin, it is at level 3. So yung root naman natin or yung starting point natin, siya na yung starting point, so it's at level 0. So kahit disregarding mo muna yung mga connections, may kita natin dito, lahat na magkaka-level, pare-pareho yun naman. And we can see actually na nasa level 3 siya. Then we can see any level na nasa gitna is level K. And then dito sa dulo, we use a special term called D or depth as yung ating deepest level sa ating tree. So, so medyo baliktad nga, no? So yung tree natin medyo lumulubog. So meron siya tinatawag na depth. So which is yung pinaka maraming levels or yung deepest level ng ating tree. So going back din sa ating material, basically ito lang din yung sinabi ko dito. And actually, notice din natin, wala nang mga T of N na terms. Puro F at saka G terms. So, technically, pwede na natin makuha yung ating time complexity dito. Ang kailangan na lang natin gawin is to add up all the terms in our recursion tree. So, ayun, pwede natin gawin. Instead of i-add natin ng minsanan, let's try to add them per level. So, for level 0, f of n lang siya. And then for level 1, it's 2 times f of n minus 1. Then for level 2, it's 4 times f of n minus 2. Then actually, similar doon sa substitution method, medyo kailangan mo ng konting abstract reasoning, kumbaga, to find the pattern ng ating total per level. So, for example, dito sa 3, we have 8. And actually, man-notice nyo dito, nag-start tayo with 1, and then naging 2, naging 4, naging 8. And you can expect yung next level natin would have 16, and then 32, and so on and so forth. So lahat sila ay power of 2. So yung ating general expression per level can be T of k is equal to 2 to the k times f of n minus k. So, ayun, we can confirm this. Pag pinlog in natin si 3, that is 8. Can write it down. That is, pag T of 3, that is 8 times f of n minus 3. Sorry, medyo pangit yung sulat. And when we go back dun sa ating recursion tree, we get, yun nga, 8 instances ng f of n minus 3 at level 3. So, ayun, there can be other methods that can be used to prove this, pero hindi pa siya natin covered for now. So, ano yung difference nun? So, we have an expression for T of k. So, yung kanina, pag sa substitution method, medyo tapos na. Pero dito sa 3, medyo mas madaling mahanap yung expression for k, pero meron tayong extra step. So recall na ito ay per level, and we want to get the total of all levels. So kailangan natin makapunta sa summation. So note lang na meron tayong konting jump dito. We assume that f of n is constant or c. So diba, kahit n or n minus 1, n minus 2, magiging c na lang siya. And then we add a summation from level 0 hanggang level d minus 1. Kasi from 0 to d minus 1, doon tayo sumusunod kay f of 1. And then for the last level, we have d and multiplied to 2 to the d. So kung meron tayong 2 to the d minus 1 na entries dito, meron tayong 2 to the d na g of x terms dito. So, ayun. So, makukuha mo yun dun sa paggawa mo ng recurrence tree. So, itong summation na to, ayun. So, actually yung D, sinabi kanina, depth is yung ating deepest level ng ating tree. So, ayun, actually kaya na natin dapat isolve to, pero hindi natin alam kung anong value ni. So ito, finding D can be done in multiple ways. So one of the simplest ways is to deduce it based on our observation of the recurrence tree. So for example, at D minus 1, you can say na based dito, pag sinubstitute natin, it's 2 to the D minus 1 times f of n minus D minus 1. However, looking back at the tree, f of 1 yung mga ina-add natin na terms. So, itong term na to, itong f of n minus d minus 1, this should be equal to f of 1, which means that 1 should be equal to n minus d minus 1. So, ang ating d, makukuha natin, is equal to n. Nandito. So, now that we have a value for d, well, actually, pwede nyo rin i-deduce dito. Nag-start tayo with n, naging n minus 1, n minus 2, n minus 3, n minus, etc., etc. Naging f of 0 dito. So, pag naging 0, that means n minus n. So, yung ating last level ay d. So, there are multiple ways to get it. Pero yun nga, one of the simplest ways is yung tingnan mo dito sa isang level. We know that it's level d minus 1 and puro f of 1 yung mga ina-add natin. So, yung expression dito na sa loob kailangan mo. But either way, kung paano nyo man nakuha yun, you should get yung depth ng ating tree as equal to n. And if we substitute this back to our original expression, we can actually simplify the first term. The first term is 2 to the n minus 1 times c. And then ito nasa right-hand side is 2 to the n times g of x. So yun nga, note na yung ating summation is equal to this term. So we can look up mga simplifications ng summations online. Pero, ayun. Medyo tiwala muna dito for And then, ayun, assuming g of x is linear, so of g of x is n, our worst case time complexity will be big O, no, 2 to the n minus 1 plus 2 to the n times n. So, n times 2 to the n. So, ang log exponential ay linear of exponential. So, linear times 2 to the n yung ating time complexity ng ating function na to na binary. So, medyo malaki siya actually since going from, for example, level 0 to level 3 times 8 na nga. And then yung sa next level is times 16. So, exponential yung paglaki ng ating run time. So, ayun. Pwede rin natin i-apply itong recursion tree for the previous for our previous na na example in factorial. So, magsa-start lang siya at kung yung recurrence relation natin is constant lang natitira per level. So, essentially, gagawa ka lang. Hindi siya mukhang 3 kasi may C1, 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 C1 from level 0 to level n, essentially. And makukuha mo rin lang na, since puro constant, i-add up mo lang sila, makukuha mo lang din na constant. So, medyo hindi natin siya ma-appreciate pag dito sa naunang example. Either way, both methods should also work. And you can actually apply your substitution to this one as well. So both results or both methods should result to the same answer. So with that, ang next na gagawin natin for the week would be a formative quiz para medyo ma-solidify natin yung paggamit ng ating pag-simplify ng ating recurrence relations through additional examples dito sa formative quiz. So with that, yeah, good luck sa inyong quiz and see you next time.